Okay, these are negative electrons built up on the roller here. And these are negative electrons built up on the stator here. Okay, now, if you charge the stator using a negative ion generator, you can charge the stator with you can give it a static electric charge because it's designed like a capacitor. And you can also charge the roller. Now there's a way to do that. Now I'm going to show you what happens to the roller when you charge the stator. The roller also becomes electrically charged. The roller also carries a static charge, which means that, and the stator will carry a static charge. That means that the roller will repel the stator because they have like negative charges. But remember, the roller also has a permanent magnetic field, and the stator also has a permanent magnetic field, which means they will attract each other. And that's what I meant. There's a force here of repulsion because the static electric field here in the stator is repelling the static electric field here in the roller because I'm giving it a negative charge using a negative ion generator. And there's a force repelling, but the roller is also a permanent magnet, and the stator is also a permanent magnet, which means they will attract each other. So I think that's what John Searle meant when he said the two forces are playing tug of war with each other. Is the static electric force here repelling, and then the permanent magnetic force of the roller is attracting the permanent magnetic force of the stator, and it's wanting to attract and it's wanting to repel at the same time because there's a permanent magnetic field stored on the roller, but now there's also a static electric field. And there's a permanent magnetic field on the stator, and now there's also a static electric field on the stator. Okay, I'll show you another picture so you understand better. Okay. This is the balloon. Think of it as a stator. And this is the roller. Think of it as the pop can. Think of it as a roller. Okay, this is the second picture to show what happens. But right now, look at this. Now, say you charge this balloon, which is the stator, with a negative ion generator, it'll give it a negative charge. Now, when you assemble the pop can here, it's making direct contact with the stator, the balloon. So, what's going to happen is when you have all 12 rollers making physical contact with the stator here, the balloon, all you have to do is charge the balloon with a negative negative charge. And because the pop can or roller is making physical contact with the balloon or stator, the pop can will also carry a negative static charge. And what will happen is there's a force, right? Because the stator is also a permanent magnet, and the roller is also a permanent magnet. So the roller here is attracting to the stator here, but if you give it a strong enough negative charge, it will repel the pop can because the net static negative charge of the pop can will repel the static negative charge of the balloon. And in the second video here, picture here, you can see what happens. The negative static charge on the stator here, which is the balloon, will repel the static negative charge on the roller here, which has a static negative charge. And there's a force right here because they both have a static negative charge. So they're wanting to repel each other. But because the roller here is also a permanent magnet, and the stator here is also a permanent magnet, they're going to want to attract each other. That's what I'm trying to